Hi guys, so last week we learned about covalent bonds. Today we're going to go over ionic and metallic bonds. This is chapter 11, lesson 3 in your science book, so let's go ahead and get started. And just as a reminder, remember when you're watching these lessons, make sure you're doing the reading as well because the reading goes into great detail and it has, your book has a ton of great examples and tables, so make sure that you're doing the reading in addition to watching these videos. So last week we talked about covalent bonds. Those are bonds between non-metal atoms. Today we're going to talk about ionic bonds and metallic bonds, which both involve some type of metal atom. Let's go ahead and get started talking about ionic bonds first. Okay, so as we learned before in previous cycles, ions are atoms which have lost or gained an electron. We'll talk a little bit more about that in a moment. Last week we went over covalent bonds, which is when nonmetals form a compound by sharing valence electrons. This is not the case when a metal and a nonmetal bond. So remember, covalent bonds, which is over here in this little diagram, are when two nonmetals share electrons together. They share them and they form a covalent bond. But in an ionic bond, we're taking a nonmetal and a metal atom and forming a bond between those two. So how does that work? Well, valence electrons are still in the mix, except it doesn't work quite the same. Rather than sharing the electrons, one electron transfers over to the other atom. So what normally happens is the metal atom loses its valence electron, and that valence electron moves over to the non-metal. And that forms two what? Ions. Do you remember when we learned about ions before in previous cycles? Remember, again, an ion is when an atom doesn't have the same number of protons and electrons. So in this case, one ion and another ion are formed when a metallic and a non-metallic atom have a transfer of valence electrons. So just to recap on ions, an ion is an atom that no longer is electrically neutral because it's gained or lost valence electrons. The atom that loses the valence electron becomes an ion with a positive charge. Why is this? It's because it then has more protons, right? Protons are the positive charge, and it's losing one of its negative charged electrons. So therefore, it's a positive ion. And vice versa. If an atom gains an electron, then that means it has more what? Yes, more negative charge. So then it becomes a negative ion. We learned about this in previous cycles, but it's just good to recap. So losing a valence electron can stabilize atoms in some instances, such as in sodium. So if you go to your book on page 399, it gives a great example in the charts of how sodium basically stabilizes when it loses a valence electron. Why is this? Well, if you look at your book, you'll see that sodium has one valence electron. Okay, it's in group 11. So when it loses that valence electron, and again, look at your book for the example of this, then that's no longer, because it was just that one, when it loses it, that's no longer the valence electron ring. And it goes down to the next ring, which has, you guessed it, 8 electrons in that next ring. So by losing that outer ring of 1, the next outer ring has 8, which is the number of completion. So it actually stabilizes by losing the valence electron. And again, I'm describing this, but if you just look at the chart on page 399, it does a great job of giving you a visual. And the same can be said for gaining a valence electron. Your book gives you a great example with this for chlorine atoms as well. So check that out in the chart on page 399. This is just to kind of give you a visual of what we were just talking about. So sodium has one valence electron. It's in group 11. And when it loses that outer electron, this ring, then becomes the valence electron ring. And so let's count 1, 2, 3, 4, 5, 6, 7, 8. That's the number that we're looking for stabilization. And so by losing that outer electron, sodium is able to stabilize. So how do we determine an ion's charge? Well, we've already talked about this a little bit. If an ion has more protons, it's what? Yes, it is positive. And if it has more electrons, it's negative. So there's a really easy way to determine an ion's charge. All you're going to do is you're going to take the number of protons and subtract the number of electrons. So for example, if we have an atom with 7 protons and 10 electrons, then the charge is -3. And it's actually not an atom at that point, but an ion. So for example, a nitrogen ion has a -3 charge. It's written as N3 with a little negative sign. This is very basic math. And it's pretty simple to do, right? It's pretty much common sense. So again, how do you determine the ionic charge? You're subtracting you're taking the number of protons and subtracting the number of electrons. Your book gives you some examples on page 400 if you want to look over those, and we'll talk about some of those live in class as well. Okay, so ionic bonds form when the attraction between positively and negatively charged ions bring them together. That's called an ionic bond. So the negatively charged ion, which is usually the nonmetal, right, because they've gained that extra electron, is attracted to the positively charged ion, which is usually the metal because they've lost an electron. So there's a little cartoon. I always do so much better with visuals. I thought this is clever. So this atom is giving one of its valence electrons to the other atom. You can see it's like proposing. And that's how they're bonded together. So when one becomes negative and one becomes positive, they're then drawn together. They're attracted to each other at that point. And that's how ionic bonds are formed. Ionic compounds are usually solid and brittle with a high melting and boiling point. And they also usually will dissolve in water. Now, we actually talked about a lot of these characteristics earlier on in the cycle. So you kind of already knew a lot of these things. Now you're just learning why it is so, why it works the way it does. Let's compare ionic bonds and covalent bonds. So we went over covalent bonds last week. We know that that's when two nonmetals share valence electrons. With ionic bonds, remember, we just learned they're not sharing electrons. They are transferring electrons, right? So covalent bonds, remember that's between nonmetals, create compounds that share electrons that form molecules. With ionic bonds, there's no molecules. They create compounds, they're attracted to each other, but a molecule is not created. Instead, there's a large collection of oppositely charged ions which are attracted to each other. And you'll see that demonstrated here. Finally, your book talks about metallic bonds. Metallic bonds are when two metal atoms are attracted to each other. So remember, we've done first covalent is two nonmetal. Ionic is a metal and a nonmetal. And the metallic bonds, you guessed it, two metal atoms. And this is where they share pooled valence electrons. So this looks a little bit different. They're not bonded to one other atom. Instead, a seal of electrons surrounds positive ions. So what happens is those atoms lose their lose their electrons. So they become positive ions at that point because they've lost an electron. And then those electrons, those valence electrons, are shared within a group or a sea, if you will, of the ions. So if you look at these illustrations here, the little blue and the negative dots are supposed to represent electrons being shared by this pool of positive ions. So it's a little bit different than the other two. They're all kind of community sharing them. They can flow freely. Because of this, metallic compounds are good conductors of electricity and thermal energy. Again, we've learned these properties about metallic bonds before, but now you're just kind of learning the why behind it. Oh, and oops, I have a little typo there. Sorry, that should say because. The valence electron can move from ion to ion, so they're able to move freely. Metals are often shiny because the valence electrons at the surface interact with light. Fun little fact to leave you with. So again, to recap, we have our covalent bonds, which are two nonmetals, ionic bonds, which are a metal and a nonmetal, and finally metallic bonds, which are two metals. Again, I encourage you to go back and look at your book because the charts that your book includes are great and very informative. We'll go over again this together live when we're in class. If you have any questions before then, you can always reach out to me. Otherwise, I will see you guys next time.